Okay, so for this lesson, what we are going to be getting into is the other part of the ignition system for oil heat, and that is your electrodes. So what are electrodes? Well, electrodes are metal rods that are made of specialized steel and are partially covered with a ceramic or a porcelain type insulator. These insulators are usually made of two major external diameters, and that's usually 7/16 and 9/16 of an inch. And they may be ordered in different lengths, anywhere between 4 and roughly 30 inches in length. They may also be sized on the job using a special tool that can actually cut the porcelain insulator to the actual size. So what do the porcelains actually serve? What it's actually doing is it's actually acting as a placeholder for the electrode rods so that they're actually securely in place when we put them in the burner. And they also serve as insulators, protecting the metal rod against shorting out to the nozzle assembly. So the insulators are center bored to fit the metal electrode rods. Okay, so for today, what we're going to be getting into is the other part of the ignition system that we deal with in our oil heat appliances, and that is the electrodes. So the first thing that we got to kind of understand is what is an electrode? Now, an electrode is a metal rod that is made up of specialized steel and is partially covered with a ceramic or like a porcelain type insulator. Those insulators are usually made in two major external diameters, and that's usually somewhere around 7/16 to maybe about 9/16 in diameter. And they may be ordered in individual lengths of anywhere between 4 inches to probably about 30 inches in length. Or they may be sized on the job using a special tool that's actually meant to cut the porcelain and cut everything to size. So the porcelain serves two purposes. The first purpose is that it actually secures the position of the electrodes inside the burner itself onto the nozzle assembly. The other half of it is that it serves as an insulator, and it protects the metal rod against shorting out to the nozzle assembly. Okay, the insulators are center bored right through the porcelain there to fit the metal electrode rods, and that's going to be either around an 1/8 inch to maybe about 3/32 of an inch in diameter. So the electrode holders is what permits secure and correct mounting of the porcelains and electrodes, so that even after adjusting them and doing what we need to do to them, they can't shift from any sort of vibrations or other causes or alters in their position. When it comes to inspecting and setting the electrodes, the first thing is that we got to make sure is that they're clean. Okay, we have to remove the electrodes from the burner, take them out of the holder, and physically inspect them. The best way to do so is by spraying them down with a solvent and wiping them down with clean rags. And what I mean by cleaning them, we're not just going to clean the porcelain, we're going to clean the tips of the electrodes, the metal, all that, and make sure that they're nice and clean. The porcelain should be a nice shiny white color. When it's that portion, you can honestly physically inspect the porcelain to see if there's any sort of cracks, chips, any sort of deformities that are on the porcelain itself. You can also see the condition of the electrode tips to see if they're actually worn down, overheated, and all that other stuff, and make a determination of whether or not the electrodes are still good, or if they're in need of replacement. But what I usually do when I'm looking at an electrode, if I'm in doubt about anything, I just simply change them out. It doesn't really hurt to just simply replace them, but obviously as a trained professional, you make that determination of whether or not the electrodes should be replaced, or you can continue using them. So the image here that you see is when you don't necessarily know the gaps and settings for a particular type of unit that you're dealing with. So you got to always make sure that you follow manufacturer's recommendations on what your electrode settings should be. As a rule of thumb, and again as a rule of thumb, you can set your gap to about 5/30 seconds, your electrode tip above the center of the nozzle to about 5/16, and you want to set it ahead of the nozzle about 1/16 of an inch. But again, that's just a rule of thumb. If you don't know or don't have the information available to you from the manufacturer, usually you can set them to that and it kind of gets you by. But again, you got to follow the manufacturer's recommendations and paperwork. So you always got to watch out. So like here we have another image. This one here is of your Beckett AF and AEG oil burner electrode settings. Notice, the differences between your dimensions between your F and L heads and your L2 heads and M series type stuff, because all of the dimensions on a burner can be different. So for an example here, like we have a Beckett CF500 or an 800 oil burner. The gap between or the R dimension is 3/16. The height above the center line of the nozzle is 3/16, but the distance from the tip of the electrode to the nozzle face is 1/4 of an inch. So you have to make sure that you're setting the electrodes to the recommended settings, otherwise you're going to have issues with the ignition. Another example is your Carlin EZ123. That gap or the R dimension is either an 1/8 to about 5/30 seconds wide. The height is about 5/16 of an inch. Your distance from the electrode tip to the nozzle face is either set from flush to about 1/16 of an inch. So you got to follow your recommendations and what the manufacturer recommends or is telling you that those settings should be. Now notice that every single electrode setting has at least 3 separate settings that we got to get them to. You have your gap between the two. You have your gap from the center of the nozzle to the tip of the electrode, and then you have your setting from the front face of the nozzle to the tip of the electrode. We have to make sure that all 3 of those settings are on point, otherwise you're going to start having problems. Beckett offers their T501 gauge or their Z gauge. You can purchase them from Beckett, and obviously that's a great way to set the electrodes when you're dealing with Beckett. Beckett has training videos out on how to use these types of gauges and what applications to use them on, so it's definitely something that you might want to look at when you're learning how to use these gauges. So electrode tips really should never be permitted to touch or extend into the oil spray. That's simply because of carbon bridging is going to happen. Carbon is going to build up on the tips of those electrodes, and it's ultimately going to start causing ignition failure. Ceramic insulators should always be treated gently. They should never be dropped or packed loosely in service kits. We want to make sure if we have spare ones that they're not going to be rolling around in the back of the van or keeping them in your tool bag where they're going to get cracked and chipped and all sorts of stuff. In field servicing, they should always be wiped clean with a cloth and cleaned with a solvent. If they show signs of aging or cracking, obviously you want to replace them immediately. Okay? Ignition problems is going to happen when we're dealing with oil. So correcting faulty ignition problems is always important. So delayed and faulty ignition is a primary cause for puffback. It occurs when the ignition is delayed. So due to some fault in the ignition system, this is what's going to happen. The oil vapor does not ignite until after the burner has run for some time. So really what's going on there is the oil is spraying out of the nozzle and the chamber is starting to fill up with that oil vapor. So that accumulation of vapor will all ignite all at once. So it really kind of just creates like an explosion inside the chamber. So that creates more combustion products than the venting system can actually handle. So that delayed ignition can cause soot to blow out of the draft regulator. It can make smoke blow all out of like every crevice of that boiler or furnace that you're working on. And in some severe cases, it can actually knock down your flue pipes or blow the barometric damper simply clear across the room. So puffback is an issue that a lot of oil burner technicians do run into, simply due to the fact that, you know, oil burners in some cases are not maintained very well. So it's something that we got to keep in the back of our minds. Ignition problems are usually the easiest to recognize and solve. So in most cases, really what we want to do is find it necessary to clean the electrodes, clean the cables if there are any there. You want to be certain that all of your connections are tight and make sure that the spark gap is in the proper adjustment. Okay? And make certain that the electrode porcelain and the transformer terminal porcelain insulators are not grazed or have small little cracks on the surface. You want to make sure that they don't have any real massive cracks in them or they're oil soaked. Okay, if you have oil-soaked electrodes, that's a whole other set of information, clues to telling you what is actually wrong. It's important that all exposed metallic components on the ignition system be a safe distance away from any other metallic part of the burner, since it is grounded. And the best way to avoid this problem is to strictly adhere to the recommended electrode tip settings as shown in the manufacturer's recommendations. That is, if you notice how important that is, your electrode settings need to be set correctly. Okay, so troubleshooting a lot of your ignition problems can be relatively easy. It usually just starts off with, honestly, the obvious things that we should be checking for, like connections at your transformer junction box are loose. Okay, so you find that stuff. You should always check line voltage connections from the neutral wire of the primary control and the orange wire of the primary control if you're dealing with intermittent ignition, and the ignition wire of the primary if you're dealing with interrupted ignition, to determine if there are loose connections at this junction box. If they are loose, tighten them. Right? Always check for loose connections at all of your terminals and make sure that the wire nuts are tight. Okay, if you're testing a transformer, make sure that you use proper troubleshooting procedures when you're testing a transformer. Is it a solid state igniter or is it an old style ignition 10,000 volt transformer? Loose connections at either the secondary terminal of the transformer or loose connections where the high tension leads or bus bars are fastened to the electrodes is another common issue that you might find in oil. If these connections are found to be loose, attempt to tighten them. Okay? If this fails to solve the problem, replace the connectors. Okay? Also clean out any dust or dirt that may have accumulated in or around the secondary terminal of the transformer. Check the high voltage leads to determine if the insulation has become defective. So a lot of this stuff is simply just physically looking at the stuff and seeing what is wrong. Okay, remove the porcelain insulator from the electrode holders to determine whether they are cracked. Well, that's just a simple pull them out and look. Okay, carbonized insulators. Carbon accumulation on the ceramic insulators will conduct electricity. Therefore, it's going to cause a spark to short out against either the nozzle adapter, nozzle line, or the electrode holder. Okay, the carbon must be removed with a solvent and cleaner. Then the insulators must be dried and checked for cracks and or spark leakage. Okay, so again, looking at the electrodes, are they dirty? If they're dirty, you take them out, you clean them. If they're really in bad condition, put a new set in and reset the electrode gaps and make sure that everything is where it's supposed to be. Electrodes in oil spray. Okay, if the electrode tips are permitted to operate while extending into the oil spray, it will promote a carbon bridge between the electrode tips, thus shorting out the spark and ultimately causing ignition failure. So again, you got to check the electrode tips and set them properly. Okay, electrodes are too close to the nozzle. Okay, the electrodes set too close to the nozzle will promote spark shorting out from the electrode tip to the nozzle, thus creating a delayed ignition or ignition failure. Set the electrode tips according to the prescribed procedures. A telltale sign that you might have this issue is when you pull out the nozzle assembly and you look at the tip of the nozzle. Sometimes the nozzle will actually have like a discoloration, almost like a burn mark on it. That's a telltale sign that the electrodes are actually maybe too close to the nozzle. Okay, a spark gap too wide. If the spark gap is too wide, it either will be no spark at all, or the spark will short out at some point along the ignition system. So obviously, again, set the tips as instructed. Okay, your insulators are not held securely. In the event the electrode support bracket is too loose or the porcelain do not fit properly in the bracket, it is possible that the electrodes may move out of adjustment because of burner vibrations. Set the electrodes and tighten the electrode support bracket securely, but do not over tighten them because you may crack the ceramic insulator. Puff back may be caused by lack of draft. Okay, if it is discovered that the ceramic insulators are heavily sooted or are carbonized and the electrode tips are properly gapped and properly set, then it's probably a good possibility that you actually have a problem with the overfire draft on the burner itself, and obviously that's going to take some troubleshooting to figure out why that's happening. Ignition on time should be checked. And obviously this is more concerning if you're dealing with interrupted ignition primary controls, but the ignition on time is easily checked by connecting one lead to a 40-watt test light to the ignition wire on the primary and connecting the other lead to neutral or the white wire, and then start the burner while watching the bulb time to determine the length of time it is actually on. Okay, when dealing with a CAD cell type control, it should remain on for the length of time specified by the manufacturer.